All right, today we're going to cover Objective 15. We are going to solve quadratic equations by factoring. Okay, by factoring. Yesterday we solved by graphing. Monday and Tuesday we're going to look at quadratic formula and we're going to look at completing the square. All of these ways will give you the same answer, right? Like today, you can solve it by factoring. What would be a great way for you to check your answers? Graph it and see if you get the same answers. But let me ask you, each way has its benefit. What's good about graphing? Yeah, you can just plug numbers in, right? And just punch buttons and it'll give you, as long as you understand how to work and how to find your zeros and go left bound and right bound correctly, you can just punch it in and get it. So it doesn't take a lot of like mathematical power, right? So you do have to understand what it means, that you'll see a parabola and where your answers are located and what buttons to push. So that's what's good about it. What's bad about it? If they're too close, we talked about this yesterday. If they're too close, sometimes people only end up getting one answer because they only think it touches once when it's actually touching twice. So you got to know to play with your zoom in and zoom out. Okay, what else is bad about graphing? Some people just don't like the buttons and stuff because it does confuse them. Okay, so if you're not into that, you may not like that. But what else? I told you, Thursday and Friday only.
No solution.
You could get no solution, but that's not really correct, is it, right? Because there's no real solutions, but there are imaginary solutions. So what's bad about graphing? You cannot get your imaginaries. You can't get your imaginaries from graphing. So graphing is not, you can't go, oh, I like graphing and I'm going to do graphing every way. You're not going to be able to hold that. You're not going to be able to do that all the time, because if it's no solution, you're going to have to be able to get your imaginaries. And so same thing with factoring. What's good about factoring? No, you can't. You still can't get, so today's the last day of the sale. Today only, we're only looking at reals, okay? You can't, so that's what's bad about factoring too. You still can't get to your imaginaries, okay? What about problems like this? Oh, here we go. Let's go back one. What about if I have x squared plus 1x plus 2, and I want to factor that? It's trinomial, right? Trinomials break into two binomials, so I have x and x. What's the issue? Well, I don't necessarily want it to cancel. It's a 1. There's no way you can multiply to be 2 and add to be 1 in the middle. So what do we know about this problem? It doesn't mean it's no solution. It just means that it's not factorable. Like, what if it's crossing in the middle? What if it's at a decimal? Does that make sense? Not all problems are factorable. So it might mean no solution. I actually think this problem means no real solution. I think there are imaginary answers to this problem because we put it in our calculator and tested it out, second block, and it's not touching. But there are problems that it's not factorable, but it does cross and they're decimals. Does that make sense? They're decimals. So here's what I want to tell you is not every problem is factorable. Not every problem can you factor into monomials and binomials and trinomials, okay? It just isn't going to work, okay? So it's good if you can factor. And most of us feel really comfortable with our factoring skills. So if we can factor, you know, if it is factorable, that's the way I like to do it because I'm good with my math skills, and most of you are too. So if it is factorable, factoring is a great way to do it. But I want you to understand, not all problems are factorable. So you can't rely solely on factoring. Now, you know what's good about quadratic formula and completing the square on Monday? Everything. It always works. Always. It's a surefire way to get your answer. It gives you your real ones. It gives you your imaginary ones. Those are the two ways that I would put a lot of stock into. Does that make sense? This works only for some of the problems. Problems that are factorable and problems that are real. Okay? So let's review really quickly. What are some ways to factor? I hear GCF. What else? Difference of two squares. What else? Grouping. Difference of two squares. GCF. Grouping. You forgot the main way. Well, we know sum and difference of cubes. We do know that. We know one more. How about a basic trinomial? Like that factors into two binomials, right? That you do the reverse of FOIL. So you got those ways as well. So just refreshing your memory. Now, I will tell you, I did not include on here sum and difference of cubes. If it's a sum and difference of cubes, that means x is raised to the third power. What are we solving? Quadratics. So we're solving equations where x is raised to the second, right? So are we going to do these cubes? So no, we're not gonna have to worry about the sum and difference of cubes today. And I'll tell you too, this grouping means it's going to have how many terms? 4. So tell me, generally, not always, but generally, things go down in order, right? Degree of this, degree of this, degree of this, degree of this. They go down in descending order. So if it has 4 terms, what would the largest be? X to the third, then x to the second, then x, and then like a number. Does that make sense? That would be an example of grouping. And so my question is, will that be a quadratic? So guess what I can do with grouping today? I can throw it out. So basically, we're going to be looking at these 3 ways to factor. These 3 ways to factor. If you wanted to add sum and difference of cubes in there, just for your notes, but you can like cross through it and say, not doing that today. If you want to add it in there. All right, so let's look at the first example. I think I have 7 examples total. So step number 1, to solve a quadratic equation, it's always got to be set equal to 0. That's step number 1, always. If it's not set equal to 0, you got to set it equal to 0 first. That's for yesterday, that's for today, that's for Monday, that's for Tuesday, that's for Wednesday. As long as we do quadratics, it's got to be set equal to 0. Okay? Step 2, then you can take what's on the left side and you can attempt to factor it. Okay? So how could this binomial factor? GCF. So I hear a 2x on the outside, and on the inside I would have x plus 9. Answer me this. Blank times blank equals 0. What do you know? If I have 2 things multiplying by 0, what do you know about one of the blanks? Jenna. One of them has to be 0 in order to get 0, right? You got to times by 0 to get 0. So either this blank has to be 0 or that blank has to be 0. Got it? Do I have that situation over here with my problem? Do I have blank times blank? 2 factors being multiplied together to give me 0? What's the first blank? 2x. It's a monomial times a binomial. Blank times blank. So what do we know? In order to get 0 over here, either this whole monomial has to be 0. What would x be? What would make that whole thing 0? 0, I agree. And right here, or the binomial, that entire thing needs to be 0. What would x be to make the whole thing 0? Negative 9. There's your answers right there. But here's what you do. It's not always that obvious. So here's what you do, like mathematically, if you want to do it like a process. At this point in time, you take each of your factors and you set them equal to 0, because that's what they need to equal, right? 2x needs to equal 0. And if you solved it and divided by 2 on both sides, x would equal 0. And then here, x plus 9 is equal to 0. And if you solved it and moved this over, x would equal negative 9. And those are your two answers. Does it make sense that I have two answers, two solutions, two zeros, two roots, two x-intercepts? Does it make sense that? Why? Why would it make sense? Because it's a parabola and it's going to cross. I guarantee if you checked it in your calculator, it would cross at the origin and it would cross at 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9. And it would look something like so. Take a minute and put it in your calculator and check it. See if it's crossing at 0 and negative 9. I do want you to understand, some people think, you know, like if I'm teaching a new lesson that I'm teaching something completely different. I want you to understand that I'm teaching you another way to get the answer, okay? When you play a sport, like if I played basketball, do I only learn one way to get the ball in the hoop? I'm going to go to trials this year and I'm going to say, Coach, I can only do layups, and that's all I can do. You're going to get cut, right? You got to be able to do it different ways and still get the same result, right? You got to be able to maybe solve in the calculator. Calculator is great sometimes, but it's not great all the time, okay? You may want to be able to factor it. Factoring is great sometimes, but if it's not factorable, it's not great all the time, okay? So you need to know multiple ways to do the same thing. Any questions? All right, so let's try this one. So step number 1, is it set equal to 0? Yes. So go ahead and try to factor it. And if you have time, if you solve it, take time to put it in your calculator and check it. How do we factor this guy? Take out an x, right? Still GCF. So far, so good? So, do I still have two things being multiplied to give you 0? Yes. Some people like the GCF on the outside, that confuses them. So don't forget, you have to set both equal to 0. So when I set this equal to 0, what is it? Is there any solving to do? No. And then you set the next one. What do you notice about the factor versus where it's actually crossing? What do you notice like here? X minus 5. The factor is negative 5, x minus 5. When it crosses at positive 5, right? It's opposite. And so we're going to use that a lot. You need to understand that your factors are opposite from the 0, from the solution, from the root, from the x-intercept, from the answer. The factors are opposite. Okay? Any questions about that? Okay. Moving right along. Is it set equal to 0? Yes. Which way of factoring do I have? Difference of two squares. Very good. Okay. So when I factor it, it factors into x and plus 3 and minus 3. And then when I set it equal to 0, x is equal to negative 3 and x is equal to positive 3. And I would venture to say, if you put it in your calculator, do take time to put it in your calculator and refresh. If you don't practice going left bound, right bound with things, you're going to forget it. So do take time today, like your homework or your classwork, I don't intend for it to be homework, says solve by factoring, check by graphing. Okay, and I'm going to tell you this. I'm going to be pretty strict on this. Would some people venture to say, well, I'm just going to put a calculator and just get my answer that way? I want to see the factors for your answers. I want to see your factors. I want to see how you break it down and that you can factor it. Okay, it'll be a good practice for us for factoring. So I want to make sure that everybody is solving by factoring. Now, here's the thing. What if you're not good at factoring, which you should be good by now, but what if you're not good at it, and it's crossing at positive 3, and it's crossing at negative 3? How can you use your calculator to help you get to the factors? Well, they're just opposite. If it's crossing at positive 3, what's the factor? X minus 3. If it's crossing at negative 3, what's the factor? I'm okay for you to, you know what I mean? Like, use your, if you're stuck on, like, I don't know what factors to use your calculator and make the connection to help you get your factors. Okay? That they are the opposite. They will on your SOL, it's not always working from the problem to the answer. In Algebra 2, they will do this. They will give you a picture, and they will say, what are the factors? Who can tell me the factors of that? If it's crossing at negative 4, what's the factor? Say the whole factor. X plus 4. Okay? And if it's crossing at positive 2, what's the factor? X minus 2. They might even say, what's the equation? They might give you the picture, and they say, what's the equation that models that? And you have to type the equation in. How do you go from the answer all the way back through to get the equation? All you got to do is get your factors, set it equal to 0, and then just take it and FOIL it. That would be negative 2 and 4, so that would be a positive 2 in the middle, and that would be a negative 8 on the end. Does that make sense? And then you could get your equation. Do you understand? If you want to be the best at quadratic equations, you need to be able to go forward and backward. If I go to basketball tryouts today, and I say, that would be a funny sight, just saying, and say, Coach, I can only play offense. That's all I can do. Just put me in on offense. Do you make the team or not make the team? No, you got to play both directions, don't you? Okay, if you want to be good at working quadratics, you better be able to go from the equation down to the answers, to the solutions, to the zeros, and then you better be able to be given the zeros or the roots or the where it's crossing the x-axis, a picture, and be able to work all the way back to the problem. You better be able to go forward and backward. Okay? All right, try that one. Is it set equal to 0? Yes, so you can factor it. Eventually, what will happen? It won't be set equal to 0, and we'll have to fix it. How many like this because without even writing anything down, you already knew the answers? Yeah. What are the factors of that one? 4 and 5. The factors are 4 and 5. What are the zeros? Negative 4 and negative 5. Okay? I do caution you, though. Where do people mess up? Well, like the signs. They get messed up on the signs. Okay? They'll look at it and they'll say, oh, that's x plus 4, x plus 5, so the answer is 4 and 5. Because those are the factors. But I need you to understand that the factors are opposite from what? The x-intercepts. Or they're opposite from the zeros. Or they're opposite from the solutions. Or they're opposite from the roots. All of those things where it's crossing the x-axis. The factors are opposite. So when you factor this, x and plus 4 and plus 5, and you end up with x equals negative 4 and x equals negative 5. Any questions on that? Somebody earlier said, Miss Corns, why is it opposite? Because it's what I can plug in. I'm not looking at this number. Negative 4 is what I can plug in for x that does what? Makes it equal to 0. Okay, so that is why it's the opposite. It's what you plug in for x that makes it equal to 0. Okay, besides checking it in the calculator, how else could you check it? You can plug it in and make sure that that whole side equals 0. Does that make sense? Check it and see if it makes it equal to 0. So what are the factors? X and plus 3 and minus 8. Okay, so that's not the answer. What are the solutions? X is negative 3 and x is positive 8. Any questions on that? You can put it in your calculator to check it. All right, almost finished. We got 2 more. What's different about this one? Actually, I think there's 2 more. Sorry, there's 8. Sorry about that. So what's different about this one? It's not equal to 0. So what's the very first step that needs to happen? You need to move the negative 4 over. So when you move this over, what needs to happen before you can factor it? You got to combine your like terms. So 2x squared plus 2x minus 24. Then what? Yes, the best factors in the whole wide world? Find the GCF first. So we would take out a 2 and be left with x squared plus minus. So far, so good? Oops. Take out the GCF first. Then what? Then we're going to factor it. X and plus 4 and minus 3. Then what? X is equal to, bless you, negative 4 and x is equal to, what do I do about the, isn't he a factor 2? Can I set 2 equal to 0? If you go home today and you say, I learned in algebra today that 2 is equal to 0, they're going to think you're crazy, right? Because that's not possible. So what can you actually do in this case? If your GCF does not include a variable, you can throw it out. Does that make sense? You don't have to worry about setting it equal to 0. You only have to set what? What am I focused on? Solving for x, because we're solving for an equation. So you only have to focus on the factors that have variables with it. Okay? You all right, Nate? Did I lose you? Well, I mean, it's still a factor, but when you look at your graph, if you put this guy into your calculator right now, put him in. He's still a factor. He's still what multiplies to be. But in this case, I'm only worried about what x is. I'm trying to solve for x. So I just don't have to consider him and setting him equal to 0. Does that make sense? Because you can't say this. You can't say 2 is equal to 0. You can't do that. That's not possible. Okay, that's not equal to 0. Okay, so I only worry about the ones that have the x's. So when you look at it, where's it crossing? At -4, +3. You only work, as far as figuring out the x's, he is a factor. He is important. But as far as figuring out and solving for x, you only worry about the factors that have x's. Because that's what your goal is. Your goal is to figure out what x would be. What can you plug in that would make that equal to 0? Does that help a little bit? Okay. Now 2 more. I promise. 2 more. So what would be step number 1 on this? Move the -6 over. And then I want you to go ahead and factor it. Take a minute and factor it. All right, here we go. So when we factor this, let's go backwards. How many were able to get it factored correctly? How many struggled just a little bit getting it factored correctly? All right, let's take a look at it. So first times first, what times what is 5x squared? 5x and x. And then last times last is 6. So it's either going to be 6 and 1 or 2 and 3. Remember what it was my key to helping you out with this. Always start with the 2 that are closest together. So I'm going to start with the 2 and 3. Okay, but you just, and it's not, everyone's like, well, 2 and 3 don't have to be 17. But whatever you put here is going to multiply with that and this to give you the middle. That's how, you know, when you check it, you FOIL it out and you work it out. So I'm thinking a 3 here and a 2 there because this is going to give me 15. And then there I'm going to have 2. So 15 and 2 will give me 17 in the middle. Does that make sense when you FOIL it out? Okay. So the question was, okay, what does that mean when you solve it? Well, this part's pretty easy. We know it's the opposite. X is equal to -3. But then everybody says, Ms. Corns, what about that? Okay. So this is one that's not as obvious. So what did I tell you? Like in the beginning of the lesson, I said, if you want technical terms, because I said they're not always going to be that easy. At this point in time, you take both your factors and you set them equal to 0 and you solve them. So I would set this 5x plus 2 equal to 0 and I'm going to solve it. I'm going to move the 2 over and make that -2. Then I'm going to divide by 5. So x is going to be equal to -2/5. So it's a fraction as your answer. Okay? Any questions on that? So it's not always just the opposite. Sometimes you actually have to solve it. You have to move it over. If it's got a coefficient in the front, if it's got a number in front of the x, you'll have to work it like this. If the x is already by itself, like this guy right here, then it's just the opposite. Okay? Question? I like, if you're solving it algebraically, I like fractions. Okay? Now when you plug it in your calculator, what are you going to get in your calculator when you check this? -0.4. Does that make sense? You'll get a decimal. But how can you check to see if -0.4 and -2/5 is the same thing? Just math, enter, and change it to a fraction. See if you get the same thing that you got there. Or you can divide that and get -0.4. But I prefer fraction. So, while we're talking about this, let me ask you this. Let me do this first. Let me give you the challenge first. See if you can figure it out. So, I told you sometimes you'd have to work backwards. Well, it's not always going to be easy peasy in Algebra 2. Okay? It's not, we know this factor. What's this factor? X plus 4, right? If it's crossing at -4, then the factor is x plus 4. My question is, this is a very good SOL question. What is this factor? Okay? Try it on your paper. See if you can figure out what that factor is. And I'm going to tell you right now, do we ever have factors that look like this with decimals? Do we ever have factors that look like this? Do you ever see a binomial times a binomial that says with fractions? No, we don't do that. So I want you to work it out and see if you can come up with it. I'm going to come look at your papers and see what we get. A minute ago, we ended up with, let me clear this out. We ended up with x equals negative 2/5, and we'll cover it when we get back from lunch. All right, so we were talking about that on this problem right here, not that problem, this problem, that you ended up with x equals negative 2/5. The question is when you have a fraction as your zero, how do you work backwards to get the factor? So let's think about this first. We had 2x, nope, we didn't have 2x, we had 5x. We had 5x plus 2 equals 0. Is that not what we started with when we set it equal to 0? So in order to solve this, we moved the 2 over, and it was 5x equals negative 2. Then we divided by 5, right? And we got x was negative 2/5. Well, let's go backwards. Let's undo all of this. Let's just go, instead of going the right way, we're just going to go, and we're going to go backwards. So, do y'all like that? Okay. So, what was the very last step that we did? We divided by 5. So what should I do? Okay, let's go backwards. Let's multiply by 5. So if I do that, I get 5x, and the 5's cancel, and I get negative 2. Then what did I do to get it back to set equal to 0? We moved the negative 2 over, and we added 2. And that's our factor, right? The factor was 5x plus 2. So let's think about this. Is I gave you the problem, and what was the 0? X was what? 0.5 or 1/2. I like fraction. Okay. Like what if it's crossing at 3.5? Do you guys know what that is as a fraction? 3.5. 7/2, right? You can, don't forget, you can, how could you, like if it was crossing at 3.5, you wouldn't want to like do it in decimal form to solve it back. We don't do factors in decimals. We do it like in terms of this. So how could you make that a fraction? Well, you could put it in your calculator and go math enter. Like if it was crossing at 3.5, you could go 3.5 and go math enter, and then that would be 7/2. Does that make sense? So you could use your fraction to do that. So here we go. Let's work backwards. If I want to work backwards to the factor, let's undo. So what would I undo first? I would multiply by 2 and get 2x equals 1. Then what? Then I would move the 1 over. And so the factor should have been the quantity of 2x minus 1. So for that particular answer, I believe it was x plus 4 and 2x minus 1. Those would have been the two factors. So let me give you one more of those before we do our last example. So what are the factors of that? Give me the factors. So this is crossing at 3. So what's the factor? X minus 3 is the factor. Don't just say negative 3. X minus 3 is the factor. This is crossing at negative 3/2. So what's the factor? 2x, not minus 3, plus 3. 2x plus 3. So again, let me just recap. If x is equal to negative 3/2, everybody agree? That's what your x is equal to. That's your 0. That's your root. That's your solution. That's your x-intercept. That's what x is equal to. But if I want to work backwards to the factor and set it equal to 0, what would I do with it? The very first thing, ooh, yuck, gross, disgusting, nasty fractions, get rid of them. Multiply by 2. So I get 2x equals negative 3. Then what? Move the 3 over, and so 2x plus 3. And so there's your factor. 2x plus 3. Yes? No. Where's it crossing at? It's crossing at negative. What's opposite? The actual point itself is negative 3/2. Okay? Does that make sense? That's where it's crossing. Where it's crossing is and this is a great question that you're asking because people get confused on like, when I thought you said it was the opposite. What did I say was the opposite? The factor. My factor is positive. Does that make sense? My factor is opposite. But where it's crossing is on the negative side of the graph. That's negative 3/2. Okay? Does that make sense? It's crossing at negative 1.5. Does that answer your question? The only thing that is opposite is the factor. Okay? Like, for example, this 3 right here, what is that 3? That 3 is it's a positive, but what is it? It's your solution. 3 is your solution. What else is 3? Your 0, your x-intercept, your root. Anything else? Okay, it's everything. The only thing that is opposite is the factor. Okay, the factor is opposite. That is the only thing that is opposite. Okay, everything else is positive 3. All right, last one. It does have purpose. What's the purpose of it? It's not set equal to 0. And when we move that negative 29x over, where does he go? In the middle. Why in the middle? Yeah, it goes down in standard form in descending order by degree. Okay? So make sure you put the negative 29x, when you move it over, it makes it a positive. It goes in the middle. All right, so 7x times x is 7x squared. Everybody agree? What should go in my binomials? Plus 1 and plus 4. That gives you 28. That gives you 1. So that gives you 29. How many were able to get there? Good. Am I finished? These are my factors. So I need to solve for x. This one's fairly easy. X is going to be equal to negative 4. And everybody says, Ms. Corns, is it okay if I don't set that one equal to 0? Yes, I understand that you can tell me that that's negative 4. But this guy, does he need to be set equal to 0? I would. I mean, how many are able to solve that in your head? Several of us, but the majority of us need to say 7x plus 1 is equal to 0. And I would set it up just so that what? We don't make careless errors. So x is equal to negative 1/7. Okay? Any questions? What's a good way to check? Plug it in, see if it's equal to 0 or graph it. Okay? Any questions?